Okay, morning. Right, whilst I just sort myself out with me paper and bits, you've got something to think about here. Oh gosh, I'm having a massive stretch. Oh, okay, so let's think about how many circles can you draw inside this space without any overlaps. So you can, if you've got the workbooks, you can do it in there, or you can think about it, or if you've just got a piece of paper, you can just draw a rectangle and have a go. See what happens. Let me know. You can also head over to my Facebook page and say hi if you want to. There's a little space, I think, on there that I've left for you to say hi in. And I'm thinking now. I think I have. Hopefully I have. And yeah, please feel free to like and subscribe on here too. Right, let's get this sorted. Right, I'm not going to be long. If you have just joined, you've got something to think about here. You can do that. If you've got the workbooks, you can use the workbooks, but you can also just do it on a piece of paper or think about it. And there's somewhere to comment on Facebook if you wanna do that. If you are a commenter and you want your name reading out at the end and a little hi, a little chat, then feel free to. Right, I'm almost there. Right, okay. Good morning, that's Mal. How are you doing, guys? It's Friday. Oh, that's a new one to me. I don't know where that noise came from, but I'm feeling it. How are you guys? I am Ruth from Joyful Maths with Ruth, and this is my all ages maths lesson where we are currently doing maths in art. It's maths in motion because all the maths lessons are about doing something physical and thinking. You don't have to do any writing, but you are welcome to. You are welcome to write things down if you want to. I say it's all ages because it's genuinely aimed at all ages. So far, I know I've had from 4-year-olds to at least 64-year-olds joining in. So, please do enjoy yourself whilst you are here. Today, we are looking at curves and circles. So I'm going to do a bit of art. We're going to do a little bit of art in there. I've stolen this from a really good friend of mine who comes to our little group, our little homemade group, and she is an art teacher, and I really enjoyed this activity, so I thought I'm nabbing that one. I'm going to borrow it. Thank you ever so much. And I'll talk about the maths behind it too, because, you know, that's what we're here for. That's what we're here for, some maths. Okay, so I asked you to think about this to start with. I found on Tuesday on Facebook that I showed this at the start. We had a little chat about it, and then it was good to come back to it at the end. I'm going to do that again today. Okay? So I asked you to think about how many circles you can draw inside this space. It doesn't have to be exactly this space. It could be any rectangle without any overlaps. Now, interesting thing that came up that I did not anticipate. Totally love it when that happens, because I love how different people interpret things differently. That is one of the most exciting things about my job. What did I mean by circles and whether they could overlap or not? So it doesn't actually matter as it happens. If you've got a rectangle and you interpreted this as circles like me, where they are like block circles that you cannot draw inside, then that is one way of doing it. Okay, so you absolutely can do it like me. Other people totally interpreted it as they could be open circles like this one, and I could draw more circles inside of this circle. And some of the answers I got were cool, and we're going to explore it. We're going to explore what answers we got, but I'll show you to start with. How I was thinking about it. Okay, so I started off putting as the biggest possible circles I could fit in there, and then I squished in the next biggest possible circles that I could put in. This is how I went about it, and then I was like, well, I can fit more circles in. I can fit more of them in as I keep going. I can fit smaller and smaller ones in into these tiny spaces. And lots of the answers I got some numerical answers. I got ones where people have said, like, I've drawn 56 circles, 100. Somebody drew over 100 circles. I've got some people that said lots. Some people said, well, the smaller your circles, the more that you will fit in, which I thought was interesting. The smaller the circles you draw, the more you will fit in. And that was quite a theme. Yeah. And we'll come back to that. Keep thinking about it during the lesson. Feel free to keep coming back to this during the lesson, and I will promise to remember to come back to this at the end. I will. If I don't, remind me somehow. So circles are a geometric shape. We talked a little bit about that in the lesson where we talked about geometric shapes, because you can define them with a measurement. They've got a name, and we can define them using their geometric properties, which is a radius. That's the measurement from the center to the edge of a circle. This is called a radius. Every circle's got one. And because we can name it, we can define it, it is a geometric shape. But you don't often see geometric shapes in the natural world and the world around us. What we tend to see are organic shapes. They don't tend to repeat or have fixed things that we can measure in the same way. So what we're going to look at is curves and circles today, more organic curves. I was inspired by this artist. Well, my friend was inspired by this artist, and then I was inspired by my friend. So I guess I was inspired by the epic Shalene, and she was inspired by this awesome artist here, Susan Schuton, and the range of art called Tar Roofing Paper Series. This is just an element of it. Go to the website. Go to her website. It's absolutely epic what she has created. Absolutely amazing sculptures, and really, really beautiful and thoughtful as well. And the other person that's inspired this lesson, and is more in the workbook if you've got those for at home, is this person here, Rachel Evans, which I'll talk about in a second as well. Okay, so the art we're going to do today has been inspired by Susan Schuton, and we're going to start off. We're going to have to start off now, because this one takes a bit of time. You may even have to do a little bit afterwards, because you don't want to rush art, do you? I don't want to rush it. So I created one. I'll show you what I created last lesson, shall I? I should have brought the ones my kids did, actually, because they are actually really cool. What we're aiming for is we're going to start off with like a white. I said bring some cards or paper with you. I've suggested like using a longer bit of like white or black card or paper, but it doesn't really matter. We're going to have a longer bit that forms our original shape around the edge, and then we're going to fill it. Can you see here with curved shapes inside, and I'm using brightly coloured pieces of paper for that. Now, I did roughly a circle with this one, but I run it, when you hang it up, you don't actually end up with a circle. Can you see it ends up a bit egg-shaped there? This time I'm going to do something slightly different because I fancy changing it up. And my daughter did something like this, and I thought it was quite cool. She made it into a little love heart shape. So you feel free to make, you can either create like a circle sort of shape by just taking a strip of card. Oh, actually, I've not even talked about cutting up the card. I'm rushing on ahead, Ruth. Chill your pants. Come on. Sorry, guys, I'm going too fast here. So what you want to do is take a bit of your longer piece of paper or card that you've brought with you, and you're going to sort of fold down the edge and cut off strips. It doesn't matter how long they are because we can staple them together to make them longer, and you can cut them off to make them shorter as well. So you want to do that with your longer piece of card and some other pieces of paper as well. So I've done it. I learned last time that talking and cutting strips didn't work very well for me, so I've done it in advance. So I've got some strips of coloured paper here that I've cut off in advance too. Okay, so ignore what I was saying about bringing it together. Don't worry about that bit right now. Start cutting off your strips. I forgot because I was too organised. There we go. Lesson in being too organised. I forgot to tell you to cut the strips because I was too organised and already done it. Okay. So if you start cutting strips now, and then I'll go through what to do. All right. So this, I'll talk to you whilst you're doing your strips a little bit about this as well, which has inspired me, which I thought was really cool. I almost did this. I was so tempted to do this in the lesson, but I thought, not everyone is going to have what they need for this. So before I tell you a bit more about this artist, it's from Rachel Evans is the artist, but she got a better name than that. But just have a look at this. This is one of her pieces of art, okay, from her website. I'm going to tell you the name of the website, but if I tell you it, it's going to give something away. What do you see in that artwork? I see, what do you see? You just, whatever names, words come to mind, just like shout them out or think them or write them down, whatever you want to do with them. What do you see there? I'll give you a little minute for that because I don't want to jump in before you've had time, because sometimes the longer you look at something, the more you see, don't you? Okay, so I'll tell you some of the things that came up on Tuesday. I'll tell you some of the things that came up. Some people say galaxies. Some people said flowers, planets, stars, fireworks, fractals, circles. Can I think of any other things? I can't think of anything else off the top of my head now. But yeah, isn't it awesome? Like really bright and colourful, and we can see these patterns being repeated. Essentially, all of these are based around circles. And I mean, if like me, you were born in the 80s, you definitely had one of these, 100%. And if you don't have one, and my kids, we've got one in our house, the thing that was used to create this. I challenge you to walk into a charity shop and not find one. I could have had 10. The other name for this lady is Spirograph Girl, because this has been created with a spirograph. I didn't think everyone would have one at home, but look her up, spirographgirl.com. Absolutely incredible artwork. And if you've not used a spirograph before, absolutely you need to get your parents to take you to a charity shop and grab one, because they're just so much fun. I've been playing with one myself, but I didn't think it would be suitable for the lesson because I didn't know if everyone would have one. But if you've got the workbook, I have put in there a little link to how you can make your own, essentially out of cardboard. So that's also another option. Right, so hopefully you've been cutting some strips during that time. You may need to cut some more as you go along. I'm going to show you. So if you want to create a circular one of these, or roughly circular, you're either going to get one piece of card and loop it around and staple it together, or I'm going to get two pieces of card and you can staple it together in two separate sections like that, because I want mine to be a bit bigger. So that's what I did on Tuesday. I'm going to go for something different today. I'm going to create like a love heart shape. So I'm going to staple the bottom together. You can see this. Staple the bottom together. So they're flat. And then I'm going to bring them together like that and staple the top like inside to create, can you see that? Like a love heart shape. Just for something a little bit different. Okay, so that is your starting point. And then the idea is that inside of this, we're just going to create lots of curves with our other pieces of paper. So I said to bring some coloured or patterned pieces of paper. It looks really cool, actually, if you do it with patterned pieces of paper. And you're just going to staple it to a part of here. Staple it to a part of here. And then loop it around inside. Can you see? Loop it around inside to create some curved shapes. And you start off, I mean, that one looks like almost a circle, doesn't it? But you'll see, as you keep going, I'll show you my other one. Oh, I tell my kids not to do that all the time. As they interact with each other, like, you're going to create some more organic shapes in there and some more curves like that. Yeah, can you see that? Looks quite cool, doesn't it? It looks really cool if you hang it up with a piece of string, actually, which I need to do. I need to get like some string and hang those up so they're hanging down from there. Absolutely. So yeah, you can get bigger strips like this one. So I've got like a bigger strip. I could make it into a loop before I put it in if I want to, like that. Can you see? I've stapled it together, created a loop, and then find somewhere to staple it inside. That one might look quite cool there. No, what do you reckon? I think it needs to be over here, doesn't it? Over here like this, and staple this sections together. And whilst you're doing that, I'm going to talk to you a little bit about the maths of curves. Maths of curves. You're going to have some things to think about as well, but you should be able to keep doing this whilst I'm talking to you. Okay, so something to think about. How would you go about measuring or answering this question? So if you were given this question, how would you go about answering it? What is the distance around the coastline of the UK? So I've got a rough map here in blue of the UK. How would you go about measuring the coastline of the UK? All right, I'll let you have a little think about this, and then I'll tell you what some of the people on Facebook said, and then we'll go from there. Okay, how would you go about measuring the coastline of the UK? Feel free to shout it out, write it down, think it, whatever works for you. Whatever works for you guys. I'm still stapling bits into my love heart whilst we're doing this. I hope the noise doesn't bother you. I didn't think about that, actually. I didn't think about that. I suppose I'm quite a noisy person. You're probably used to me now. What do you reckon? What do you reckon? If you were given a map like that, lots of people talked about scales and using scales. So often a map will have a scale on it, like 1 centimetre equals like 2,000 meters in real life or something along those lines. And said that they would use the scale to answer the question, and like started talking about taking measurements around the edge of the UK, and that would be like the perimeter, we would say mathematically, the perimeter of this shape. So going round and round and round the edge of it. Can you see? So trying to go round and measure all around the edge. The difficulty is, can you see, some bits of this look relatively straight. We could probably get a relatively accurate measurement for that bit. But then we've got these bits where it's very, very curved. Can you see this bit up here? I mean, you know, we could probably make good, fair estimates on that, couldn't we? We could make good, fair estimates. What happens if we zoom right in like this? So I'm zoomed in to one tiny bit of that coastland. And you might notice, look, it's actually, yeah, probably that sticky outy bit there is on the map, but it's every little bit of this. Can you see all these lumps and bumps and different little bits that we can see that just wouldn't be represented on that map? They wouldn't be on there because the scale is much too big. So when we zoom in, what's going to happen to that length, that distance as we zoom in? If we tried to measure it at this zoomed in scale, if we actually walked around the UK and started trying to hand measure it at this zoomed in scale, what's going to happen to that measurement of that distance around the UK? I'll give you a little bit of time to think about that. A little bit of time to think about it. What do you reckon? Do you think it would get more accurate? I think it would get more accurate, wouldn't it? It would for sure get more accurate. I would definitely get more accurate, but it would also get longer, I reckon. I think it would get considerably longer because we're no longer estimating, are we? Well, probably. Are we? We're measuring more. We're going to go more in and more out every single time. So that length, instead, where it looked like it was straight lines on the map, there's going to be lots of little bends and curves, and the coastline is going to appear much, much longer. Where if we zoom right in and measure it like that, but then mathematicians said, wait a second, if we're zooming in that much, what happens if we zoom in again? What if we zoom in even more and we start zooming in to every single shell, every single pebble, and measure around every single tiny little dent that we find on the coastline of the UK? What if we zoomed into microbes? What if we zoomed into tiny, teeny, tiny little animals? What's going to happen then? And, well, that's quite interesting mathematically, because how far can you zoom in? When do you stop? And what mathematicians say is actually, well, we've got to find a limit to this. And when we're looking at limits, we want to zoom in as much as possible. And zooming in to like an infinite amount. It's almost like we create an infinite edge around the UK where it's getting infinitely long. Only we know that's not possible. It can't get infinitely long. We know that the area of the UK is fixed, and it is going to change. Things pointed out to me on Facebook, like the tides change. You've got erosion. You've got things being deposited back as sand, for example. So you've got the changing in sea levels. So the coastline, it is going to change. It's not a fixed thing, but roughly, very roughly, it is going to stay the same. And in order to measure it, we need to think about this tending to infinity. What happens when we zoom in smaller and smaller and smaller and start thinking about the coastline? The coastline getting longer and longer and longer. Okay, I'm going to talk a little bit more about that in a minute. How are you doing with these? So this is mine so far, and I just wanted to show you, look, mine are starting to interact a bit more with each other, and the curves are changing, actually. Can you see that there's some spaces? There's space. I've not perfectly filled it in. If I zoom right in, I can like look at you through that. That's maybe a bit creepy, actually. I won't do that again. My brain sometimes my thoughts and my words bypass my brain or go a lot quicker than my brain works, and I do things like that that look a bit creepy. And that's one of those situations. So we've got little gaps in here. We can, in this case, it doesn't have to be perfect circles, so we can actually staple some of these together to change the shapes of them if you want to. Follow your artistic gut instinct. Like, do what you think looks cool. I'm quite enjoying that at the moment. That's quite a nice shape to me. It's lovely to look at. Yeah, so you keep going with that. I'm going to keep going with mine. The idea is to try and fill in as much as you can of this shape. Be creative, be inventive with it. So with the coastline of the UK, this is interesting to mathematicians because organic shapes, like we said, we can't necessarily describe them. Well, we can start describe many shapes mathematically using graphs and using formulas, but finding the area, as I talked about, like the area of the UK. So the area would be the blue bit of the land. So if we look here, see the blue bit of the land, this blue bit of coastline. So the blue bit is the area. So how much blue is there would be the area. Is in itself challenging because of these curvy edges. So mathematicians want to be able to do this. They want to be able to do this accurately. So they use this idea of zooming in more and more and more in order to be able to do that by using geometric shapes that we know about, that we can measure, that we can find the area of to estimate curves. Okay, so I'll show you an example here. So in reality, I've got an example here where we've got a little graph that's curved here. Can you see? It's called a parabola, this shape. It's a curve. It's like a U shape. Its name is a parabola. And what we've got here is somebody's, instead of looking at the area underneath the curve, the person has drawn rectangles behind it. And they've split them up really small. You can imagine if there was just 2 rectangles there would be quite a lot of extra bits sticking out. But the smaller we get, there's going to be less and less extra bits sticking out. And mathematicians went on from there and decided actually it'd be better if there were trapeziums. So trapeziums, a bit like a rectangle, but then you would do like a straight edge here. So you're making less and less extra or space each time. Okay, and you can imagine the narrower we make these, the smaller we make these rectangles, the closer we're going to get to this curve. And that's exactly what mathematicians did. They just got closer and closer and closer. They made them narrower and narrower and narrower, intended to an infinite amount of little trapeziums rather than rectangles, an infinite amount of them, and said, right, if we do that, we can say eventually we've got an infinite amount of these tiny little straight lines that we can't see. They're so, so tiny. But there's so many of them that it actually creates a curve instead of a straight line. And because we know how to find the area of this geometric shape, we can now find the area underneath the curve by tending to an infinite amount of these tiny little shapes. And that's what mathematicians did. Isn't that clever? Like, it blows my mind that I learned this in school in like a matter of weeks or months. But somebody had to actually think that up. Somebody's mind expanded to the point where they went, well, I know the area of this, and I'm just going to keep reducing it down until I can't see it anymore. And now I can work out the area of this totally new shape. I mean, to me, that's just absolutely groundbreaking. So I'm going to show you, I decided not to do this in this lesson, but I'm going to show you how to do it because you can have a play with it at home, but I just thought it'd be a bit fiddly to do live. If you've got the workbooks, I've put one in there for you to have a little go at, but it's very simple to create yourself. What I'm going to do is show you actually how we can draw that shape, that parabola shape, using only straight lines. But you can try and join in if you want to. I can't tell you what to do. You do whatever you want. But feel free to just listen and look and continue with this as well, because this is cool too. Yeah. So I'm going to show you that and talk a little bit about it and how it works. Okay. Oh man, I think I drew on my plain piece. Ruth! I always do this. I've drawn on my plain piece of paper. It's okay. We've got enough space to still do it. We're fine. Okay, so I'm just going to bring you down a little bit. Look, I drew on my plate. This is my organised. I should never be organised. Just doesn't work for me being organised. So I'm going to start off by. You can do this in different shapes, but the basic point is we need 2 lines. I'm going to do mine at a right angle. It doesn't have to be at a right angle as it happens. I'm going to draw a 10 centimetre line on the right hand side, and I'm going to mark off every centimetre. And I'm going to number them. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to draw another line. So that was my vertical line. I'm going to draw a horizontal line that's also 10 centimetres. And mark off every centimetre like this. And I'm going to number those, but this time, like backwards. So I start at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then all I'm going to do is I'm going to join up the matching numbers. So I join 1 with 1 like this, and you can see I start off, it's just a straight line. It's not very steep. It's a very shallow line, so it's really not very steep. But now when I join up 2 with 2, can you see I'm going to break that line here? So I'm going to break it up a little bit by joining 2 with 2, because that line is slightly steeper. Then when I join 3 with 3, I break the line up even more. So I end up breaking the line up even more by drawing a slightly steeper line by joining 3 with 3. And then I keep going like that. I join 4 with 4, drawing a slightly steeper line and breaking the line up into another little segment. And I keep going like this, drawing slightly steeper lines that break up the previous line a little bit more. And as we keep breaking this line up, a little bit more, and changing the gradient, the steepness of the line, you can see that what I end up doing is producing a curve. And it is a little bit optical illusion because when you zoom in, it is lots of little straight lines. But you can imagine the more and more I break this up, if I brought these numbers closer and closer together, it actually just becomes a curve. Doesn't that look cool? Lots of people said it looks almost 3D or like a bent chessboard maybe. It's quite cool if you do another one above and you do it in here too, you end up with like quite a cool shape. You can do this with all sorts of shapes. It does look really, really cool. But that shape is a curve. It's a classic curve called parabola and created entirely by straight lines. And that's what mathematicians were doing, breaking up straight lines, breaking up things they could measure to create curves so that we can measure curves. And the other thing that we can do with the same area of maths is calculate the steepness of curves as well, because previously we would only be able to calculate the steepness of a straight line, and then by breaking it down in these tiny little segments we could calculate the steepness of curves too, which I think is really, really exciting. How are we doing with this? How are we doing with this, guys? Because this is linking to our starter. I would love to see your pictures of this actually. If you can get on the Facebook and say hi. I know it's not for everyone. That's absolutely fine. I would love to see your pictures of this shared as well. Because this bit links back to our starter. I don't think I'm going to finish mine in the lesson, but what I'll do is I will finish it afterwards and I'll post a picture so you can see what it looks like. What I'll do is I'll grab this one though and show you this one. Okay, so I wasn't using circles. I wasn't using circles here, but I've used curved shapes. And potentially you can spot in this one. Look, there's like little gaps that I could fit if my stapler was small enough. It's not, but if it was, I could fit more and more circles into. I could fit a circle in there. I could fit one in there, and potentially the thing that's stopping me is how big a thing I can work with, like how nimble my fingers are, how fat they are, how big my stapler is. But if I had an infinitely tiny stapler and infinitely tiny fingers, I could keep fitting tiny little circles in there, because circles and curves, they're not going to tessellate with each other. We talked about tessellation a few weeks ago, which means tessellation is when two things fit together absolutely perfectly with no gap. So, for example, we talked about hexagons and why bees use hexagons to store, this is honeybees, to store their honey and their tiny little baby bees, because the shapes fit together, hexagons tessellate and fit together perfectly without any gaps. That means they don't have to waste any of the wax that they're using to build the hive with filling up gaps. But a circle is a very, very efficient shape. It gives a really good space inside for the amount you have to use for the outside, but not great because it doesn't tessellate. A hexagon, however, it's not quite as good as circle for the space it gives inside, but it's getting close to. It's got a really big space inside compared to how much you need for the outside. So they're really efficient. The hexagons are really good for that. But circles do not tessellate. And that links back to our problem at the start. I'm trying to find it. I'm pressing my thing the wrong way in doing it. So if we go back to this problem at the start. Either way, whatever you did, whether you did it like me with these block, what do you call them? Block circles where we can't go inside of them. Or if you were doing circles that were open and you were drawing inside of them, you can imagine I can fit more circles in here. And then I could fit some more circles in here. And I could keep going and keep going and keep going. And essentially, the thing that limits me on what I can do is the thickness of my pen, not the number of circles, because I could get a thinner pen out and I could go, right, I could fit a little circle in there, a little one in there, little One there, little one there, little one there. I could do the same. I could fill this up. I could do really big ones. I could do little ones. And no matter what size you started with, I could do massive ones. I could do tiny ones. You're always, when you zoom in, going to have these little gaps. Always, always, always. Because circles do not tessellate. There's always going to be a gap that technically, if we had a really, really tiny little pencil, really tiny little pen, we could fill it with another circle. So the limiting factor is not the size. It is actually the thickness of your pen. And technically, we could get there's not a number. There's not a number answer to it because infinity is not a number. We could get an infinite amount of circles into that space, no matter what space you drew as well, which I find amazing. Like, you could have had like a full sheet of A4 paper. You could have drawn like a tiny little square. And technically, even though we can't physically do it with our hands, we could get an infinite number of circles in there because there'll always be another gap. Always, always, always. Which I just, it blows my mind. I love infinity. I love it so much. Infinity's so cool because it's like mind-blowing, but also necessary. It makes sense all at once. Anyway, that might just be me. Right. Okay, so hopefully you're still going on with this. If you've had a chance to, if you haven't had a chance to, but you want to, do go over to Facebook and say hi. There's like a little post there where you can say hi. I'll say hi to you. Put a picture up of what you've been doing if you'd like me to have a look at that too. That would be really cool. Before I do that, I'm just going to say this is we're finishing the end of this lesson today. These lessons are free for my home ed community. I want to make sure that these are available to everyone. I've been teaching maths for 15 years. I'm Ruth, and I home educate my 2 kids as well. I do the lessons for free, and I make a bit of money by some people joining up to support these lessons for either £5 or £6 a month. And for £5 a month, I say a little thank you to people by sending out my activity book. My last one was on fractivities. So that's still coming out to people now. It's all on fractals. It's a really cool area of maths that, like, one of many amazing things that schools just seem to miss out. It gives you loads of hands-on ways to explore fractals. It's got puzzles, problems, experiments and things you can do in there. And it comes out with some origami paper and some cool stickers as a little thank you. I'm currently working on the next one, which is on weather. It's taken us a bit of time. Me and my kids like to do all the experiments and only put the good ones in. So far, we've done a lot of experiments, but not many have made the mark to go in the booklet yet. So, we're working our way through them, and it will be available when we've managed to do all that and put it together and stuff like that. It's taken a little bit longer than I anticipated. If you sign up for £6 a month, I'll also throw in downloadable workbooks where you get space to do all the stuff in the lesson. But the really cool bit is my sister-in-law puts at the back as well links to cool things you can do online and other areas to explore. So this term, because it's all about maths and art, a cool artist to look at, or maybe a couple of artists, and different ways to explore the maths and the art at home as well. Okay. That's my little spiel. Let's see if anyone wants to say hi. Where am I going? Facebook, wasn't it? I said Facebook. I did say Facebook. Excuse me. I burn incense sticks whilst I'm working because smell's really important to me. Sometimes it gets to the back of my throat. Hi! Right, who have we got here? Sophie, Emily, Katie, and Hannah. Hi, guys. Sophie wanted to show you her checkmate hat, which I guess is a circle to make relevant to the lesson. Oh my gosh. Okay. Oh, whoa! Okay, so this must be for chess, right? That is very cool. That is super cool. Can I show? Right, I need to clean my phone because it's filthy. Look at that. Isn't that cool? Can you see that? It's got a chess piece on it. That is awesome. I love how it's on fire as well. Is that like what can I it's like is it analogy for I'm on fire? I'm using the wrong words. But you know what I mean. Also, Hannah wants to say she is 3. There we go. We've got 3-year-olds to 64-year-olds at least. Woo! Awesome, Hannah. I think you're my youngest viewer, as far as I know at the moment. I think she wants to be the youngest member of the Maths Pod. Officially, youngest member of Let me start that again, Hannah. Officially, the youngest member of the Maths Mob. Thank you for joining, Hannah. Who else have we got? Hi, Bella. Looking forward to today's lesson. It's your 13th birthday in 8 days. Ah! Okay. Hi, Bella. And also 8 days. Right. Let me get that right. So you're not going to be 13 for the next lesson because your birthday will be on the Saturday. But you'll be 13 for the last lesson of this module. I think that's right. Is that right? I think so. You'll have to remind me next week. And will we sing happy birthday? Maybe we'll sing it. Yeah, you let me know. Remind me next week. Oh, and hi, Wilf. Am I saying that right? I had to double check that I said that right. Hi, Wilf. Hi there. Nice to have you here too, Wilf. Okay, I'll double check because sometimes people comment late and I just don't want to miss anyone. I don't want to miss anyone. It's really important to me. Oh, wait. There we go. Oh, we've got Freddie here too. Hi, Freddie. Nice to have you here too. Oh, and Jacob. How could Jacob, I should have guessed you would be here. Hi, Jacob. Nice to have you here. Hoping you're enjoying the beach still. Have I got anything else to say? I don't think I have. I think I've managed it all today. Yeah, I'm good. I hope you're good too. I am really looking forward to seeing you next week. When? We're doing fractals! Yeah! I've got so much to say on fractals. I had to do it. I've done it in a nature module with my small group people, puzzles and problems, and I did a booklet on it, and I've still got more. So we're doing it in art as well. So yeah, fractals next week. So excited. Thank you so much for joining me live, guys. Thank you if you're watching this recorded, and I will see you this time next week or on Tuesday for more Maths in Art. Bye for now, guys.